Okay, we are going to go over quadratic equations. And so we're going to solve using the different ways. So you have what is called the zero factor property, which is if you have a product, and it doesn't matter how many you have, but we'll just do two for this. But if you have a product and it has to be equal to zero, we've talked about this before too, in previous lessons, but I didn't give it a name. But anyways, if you have a product that's equal to zero, then either the A, like in this case, the A would have to be zero, or the B would have to be zero. One of those would have to be zero, because the only way to multiply and get zero is if one of those are zero. So for solving this here, you have -5 times x plus 4 equals 0. Well, -5 can't be 0, which means that the x plus 4 would have to be 0. So x would have to be -4. That's the only way that this product would be equal to 0. So if you have something that's like in factored form of a quadratic, so your quadratic is, you have a variable squared, whatever it is, usually x, but you might have a different variable. But if you want to solve this, so you have this times this is 0, so that means that at least one of these would have to be 0. So this one would have to be 0, or this one would have to be 0. That's the only way to get multiply and get 0. So you would have 6m plus 5 is 0, or 11m minus 6 is 0. And then you just solve both of those equations. So 6m is -5 if I subtract 5 and divide by 6. So m is -5/6. Or if I add 6, 11m is 6. So m is 6 divided by 11, 6/11. So, so if you have two things multiplied together, or 3 or 4 or however many, then at least one of those would have to be 0 in order to multiply and get 0. So what we want to do is use this zero factor property to solve quadratics by factoring. So if we want to solve by factoring, so we're going to jump to number 5 here. We have x squared minus 4 equals 0. So you could solve this using a radical. You could add 4 to both sides. You'd get x squared equals 4. Take the square root, and you have to do plus or minus. So plus or minus square root of 4 is 2. So your answers would be plus or minus 2. That's fine. But if we want to solve it by factoring, if we use the difference of squares, this would factor into x minus 2, x plus 2. Is equal to 0. So this factors into this. So for quadratics, factoring comes into play. And then you would have, so now you have a product that's equal to 0, which means this is 0 or this is 0. That's the only way to multiply and get 0. So you would have x minus 2 is 0, which means x is 2, or x plus 2 is 0, which means x is -2. So your answer would be -2 or 2. So when you have a square, you'll have two solutions unless it's a repeated solution, in which case we say it occurs 2 times. But you'll have two solutions normally, like I said, unless it's repeated. So for number 7, we have 3a squared is equal to 12. So again, you could solve this by radicals. You could divide by 3. 12 divided by 3 is 4. Take the square root of both sides, do plus or minus. You'd have a is equal to plus or minus square root of 4, which is again plus or minus 2. But what we want to do is solve it by factoring. So if I subtract my 12 over, because we want it to be equal to 0. If I factor out my greatest common factor of 3, so I factored the 3 out, so 3 is gone, and then 12 divided by 3 is 4. And now again I can use difference of squares. So this is a minus 2, a plus 2 is equal to 0. So again I have the product of 3 things now that's equal to 0, but again the first one here, if it's a number, it can't be 0. So then this has to be 0 or this has to be 0. So we'll get the same answer. A is equal to either positive 2 or a is equal to -2. So when you solve by factoring, factor it and then set each factor equal to 0, and that is your solution. And like I said, it can be repeated, which we're going to do one of those here in just a minute. So we have a squared plus 3a minus 10 is equal to 0. So if we factor this one, you've got a times a gives you the a squared. And then factors of 10 that will give you a 3 would be 5 and 2, and you want it to be positive 3, so you want the bigger number to be positive. So that's how that factors, and you can check it by foiling it, and it does go back into this. So you've got a plus 5 times a minus 2 is 0, so you have to say then either this is 0 or that's 0. So a plus 5 is 0, which means a is negative 5, or a minus 2 is 0, which means a is 2. And you can also check all of these, obviously, plug them back in, and they should work. So anytime you get your solution, you can always check. So if we have 4x squared minus 4x is equal to negative 1. So for this one, again, you want your quadratic equal to 0 to be able to factor and solve. So we're going to add 1 to both sides to get the 0 over here on the right. Or you can have 0 on the left, it doesn't matter, but you want it one side 0. And then this will factor into actually 2x minus 1 times 2x minus 1. Because you got 2x times 2x is 4x squared, minus 2x is minus 4x, and then negative 1 times negative 1 is positive 1. So this is the same thing 2 times, which is fine. So you would just set it, one of them equal to 0 because it would happen 2 times. So 2x minus 1 is 0, which means 2x is 1, so x is 1/2. And we just say that it occurs twice because we have 2 factors, but they happen to be the same factor, so that answer occurs 2 times. And there's reasons for that, you know, when you, if you take like higher level math classes, there's reasons for that. But we won't get into them in algebra. You can just set 1 equal to 0, solve it, and be done. So that's solved by factoring. So get one side 0 and everything else on the other side. Generally, you know, you put everything on the left and 0 on the right. Factor it, set each factor equal to 0, and solve those, and you're done. So if you want to solve by completing the square. So a lot of people don't like completing the square because it takes more time, generally. The factoring, I prefer factoring. If it'll factor, I'll factor it every time. You can also use the quadratic formula, which we'll get to in a minute, and it's can be quicker than completing the square. So what we are doing is, if you look at the notes that I have posted, and then I have some typed, the steps, I've got the steps numbered, and they go with what's typed out. And I don't have a printer right now. My printer quit working. And so I couldn't print them to show you, but I'll kind of verbally tell you what they are as I do this. So here's our equation, our quadratic. So your step number 1 is to get your leading coefficient to be a 1. So if this is already a 1, in this case it is, step number 1's done. Step number 2 is to get your squared term and your linear term, your first power term, on generally the left, and your constant term on the right. So step 2, we're going to, unlike with the factoring where we wanted 0 on one side, we want to put our constant on one side and then our variables on the other. So we're going to put y squared minus 5y and add 6 to both sides. So 0 plus 6 is 6. So that's step 2. Step 3 is the squared part, where you add in something squared. So what you want to do is you want to take whatever's in front of your linear term to the first power, divide it by 2, and square it, and add that to both sides. So what we're going to do is, and I write this down this way every time just so you can see something. So I always put a plus sign. I put it in parentheses. Negative 5 divided by 2, so I'm just going to write that. Negative 5 divided by 2 squared. And if I add that on the left, I have to also add it on the right, because then I'm not actually changing the equation. I'm changing it, but it's still equal. So I always write it this way. Some people go ahead and square it. So some people would go ahead and write 25/4, which is fine. But the reason I write it this way is because then this side now will factor into y, and then whatever you've put in parentheses here, slides into the spot. So I've got negative 5 halves, which means I'm going to do minus 5 halves squared. That's what that factors into. So you've completed the square. So you've added this in so that you can write it as something squared. Now, if you put, so if this is a positive, this will be a positive. If this is a if your b term's negative, this will be a negative. So that's why I write it in parentheses. So then whatever I have in parentheses, I can just slide right down here. And then is equal to 6 plus negative 5 squared is 25 fourths. So again, you do this so that you can write this whole trinomial here as something squared. So whatever you put here is what has to go here, and then you can write it as something squared. And then 6 plus 25 fourths, it's not really a numbered step, it's just simplifying the right-hand side, so that is 49 fourths. Step number 5 is that you take the square root of both sides, and just like I was saying a minute ago, if you take the square root of both sides, you have to do plus or minus. Should have put this on another sheet of paper. So y minus 5 halves, if I take the square root of both sides, is equal to plus or minus the square root of 49 fourths. So the square root of 49 is 7, and the square root of 4 is 2, so I can go ahead and do that. So again, that's just simplification. So this is 7 halves. And then step 6 is to solve for y. So, sorry, I'll have to do it over here. Didn't think to get another piece of paper, but so solve for y. To solve for y, I add 5 halves, so I've got y is equal to 5 halves plus or minus 7 halves, which means I have two answers still. I've got 5 halves plus 7 halves and 5 halves minus 7 halves. So y is 5 halves plus 7 halves, which is 6, 12 halves is 6, and y is 5 halves minus 7 halves, which is negative 2 over 2, which is negative 1. So my solutions are 6 and negative 1, and again, step 7 here is check it, and it will check. I'm not going to write it all out, but you can plug those in and they do work. So obviously if you factored this, so if you go back here and factor it, it factors into y minus 6 times y plus 1 is equal to 0. So y is either 6, which is what we got, or y is negative 1, which is also what we got. So obviously factoring would be way faster, but it's good to know how to complete the square, and completing the square is actually where you can use it to show the quadratic formula. And I've seen also graphs, if you Google it, completing the square graphs, it shows you like triangles and squares, and they come together to like complete the square, which is pretty cool. So to do another one of these, try to do a few of these because this is everybody's least favorite usually. So we have b squared minus 6b is equal to 72. So again, step 1 is make sure your leading coefficient's 1. If it's not, you have to divide by everything and get it to be 1, but in this case it is. Step 2 is you want your b squared, or whatever your variable is, but your squared term and your linear term on one side and your constant term on the right, or on the other side, but usually left and right, and that's also done for us. Step 3 is I'm going to add in half of whatever's in front of my linear term and add in the square of that. So I've got b squared minus 6b, and again, I'm just going to write it with the parentheses. I'm going to do negative 6 divided by 2 squared. And if I add it to the left, I have to also add it to the right, squared. So now if you wanted to say negative 6 divided by 2 is negative 3 and write negative 3 squared, that's fine. You could go ahead and simplify it that far at least. But you don't want to just write 9, because then the problem is if you write 9 over here, then what happens is sometimes you try to put 9 in when you do the square, but that's not what the square is. So now I can write this as a squared thing, which is b, whatever I put in here is what I'm going to put here. So I've got negative 3, so b minus 3 squared is equal to 72 plus 9. So again, if some people, if you write plus 9 here, then you try to do b plus 9 all squared, but that's not it. It's whatever you've squared. So if it's negative, this will be negative. If this were positive, this would be positive. And you can check that because b minus 3 times b minus 3, I didn't check the last one, but just so you can see it, b minus 3 squared is b squared, and then minus 3b, and then plus 9. Okay, well this is minus 6b, which is what we want. So it would be b squared minus 6b plus 9, so plus negative 3 squared is 9. So it does work, it does give you this. So you've completed the square. So 72 plus 9 gives me 81, so this is just simplification on the right hand side. And then I'll take the square root of both sides, that's step 5. So take the square root of a square cancels, and I have to remember to do plus or minus on the other side. So plus or minus square root of 81. So plus or minus the square root of 81 is plus or minus 9. And then step 6 is solve, so I would have b is 3 plus, or if I add 3 to both sides, 3, I didn't mean to write the square root, sorry, 3 plus or minus 9. So then I would have two answers. I have b is 3 plus 9, which is 12, or b is 3 minus 9, which is negative 6. And again, step 7 is just check, and both of those work if you plug them back in. Okay, so again, factoring would have been faster, but this is completing the square, and like I said, just be careful right here. So whatever you put in parentheses is what goes here, not the squared part. So don't write 9, it's actually negative 3. So for the last one with completing the square, we have 4b squared plus 8b equals 16. So this time we're going to do step number 1. Step number 1 is you want this to be a 1. So if it's not a 1, you have to divide everything by it. So I'm going to divide this by 4, this by 4, and this by 4. So now I have b squared plus 2b is equal to 4. Step 2 is make sure your constant's on the right. If it's not, move it over there. In this case, it's done for us. The constant's on that side. Step 3 is I want to divide this in half and square it and add that to both sides. So I'm going to say b squared plus 2b plus, again, I'm just going to write it as 2 divided by 2 so you know where it's coming from, squared. If you want to write 1 squared, that's fine. 4 plus 2 divided by 2 squared. So again, if you wanted, you could say that that was 1 squared instead. It's 1 squared, and this is 1 squared. But the reason we do that is so then, well, in this case, it doesn't really matter since it's 1 and 1 squared is still 1. But anyways, the reason we do that is then we can write it as b plus whatever I've put in here goes here. So it's a positive, so it's a positive 1. I had myself wondering how to write the plus, but it's a positive 1 squared is equal to 4 plus 1 squared, which is 5. So for this one, you wouldn't really necessarily make a mistake if you wrote it as just b squared plus 2b plus 1, since 1 squared is 1. And you can see that it works. If you do b plus 1 times b plus 1, you'd have b times b is b squared, and then b and another b when you did the outer and inner, so that would add up to 2b, and then 1 times 1 is 1. So you've completed the square. So now I'll take the square root of both sides. So I have b plus 1 is equal to this plus or minus the square root. Always don't forget to do plus or minus. And then solve. So I'm going to subtract 1. Oops. So b is negative 1 plus or minus square root of 5. And you can leave it. You don't have to do it as a decimal. So we'll just leave this alone. You can still check it. You can plug, if you have a calculator, you can plug in the square root of 5. It doesn't care. It will work. If you do it as a decimal, that's fine. You can plug that in and it should work. Sometimes when you round, the decimals might throw it off a little bit. So I always plug it in with the radicals so that I'm not got a rounding error, but it still works. So you can check it and make sure. So like I said, if you do these and you get a radical that can't be simplified, you can just leave it alone. You don't have to you don't have to do it as a decimal. So the next thing we're going to do is solve using the quadratic formula. So that was completing the square. And so now if we want to use the quadratic formula, and I'm going to show you how you complete the square. Some of you might have seen it before, but to refresh your memory if you haven't. So we know the quadratic formula. Most people know it, have it memorized. There's a song you can sing. I'm not going to sing for you, that would be terrible, but there is a song you can sing. So negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So the way that you can actually do it by completing the square is, I'm still going to number it just so you can see. So step 1 is you get the leading coefficient here needs to be a 1. So I'm going to divide everything by a. Right? And I'm 0 divided by a. So these are gone. So I've got x squared plus b divided by a x plus c divided by a is equal to 0. Okay. Step 2, move my constant over to the other side. So I'm going to subtract my c over a. So if I do that, then I get negative c over a. Okay. Step 3, I divide this in half and square it and add it to both sides. So, let me just go on the back of a page here. Nope, let me go over here so I don't mess it up. But if I do b over a divided by 2, if I cut that in half, that's the same thing as b over a times 1/2. Because this is division. If you write it like this, this is division, so multiply by the reciprocal. So those are equivalent. So that is b over 2a, which looks a little bit familiar because there's b over 2a, right? So I'm going to have x squared plus b divided by ax plus b divided by 2a squared. That's what I get when I divide this in half, is equal to negative c over a plus b divided by 2a squared. Okay, that's step 3. Step 4 then is to slide this in. So I'm going to complete this. So I've completed the square, I've added it in. So now I can write this as x, and then again this goes here. So x plus b divided by 2a squared is equal to negative c divided by a, and then if I square this, I get plus b squared over 2 squared's 4 and a squared's a. So now to simplify this, so I want to combine those. So let me do it over here as well so I don't mess up my... Okay, so my least common denominator would be 4a squared, which means this one is okay. It's got 4a squared. I need to make this 4a squared. So to do that, I multiply by 4a. Okay, so 4a times negative c is a negative 4ac over, let me do it this way, 4a squared plus b squared over 4a squared. Well, so if I combine these and rewrite it, instead of writing negative 4ac plus b squared, I'm going to write it as b squared minus 4ac. Doesn't matter, I can switch it around, divided by 4a squared. Okay, so this simplifies to this. So now I have x plus b divided by 2a all squared is equal to what I just simplified over here, b squared minus 4ac, which is good. It's starting to look a little like this, all divided by 4a squared. Okay, step 5, when I complete the square, is to take the square root of both sides. So take the square root of this side and it's gone. So we've got x plus b divided by 2a is equal to, and again, you got to remember plus or minus the square root of all this. So b squared minus 4ac divided by 4a squared. Okay, so now I'm going to, step 6 is solve, or I can simplify this first and then solve, whatever, or I could do it all at one time, but just to keep going in step by step. So the square root of b squared minus 4ac, I can't really do anything with that, so that's going to stay as the square root of b squared minus 4ac over the square root of 4 is 2, and the square root of a squared, because remember, radicals you can split if you have a quotient, and inside a radical, a fraction, you can do the square root of the top divided by the square root of the bottom. That's fine. So the square root of 4 is 2, and the square root of a squared is a. Okay, so step 6 is subtract this over, so I've got x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac divided by 2a. Well, they have a common denominator, so I can write them as one thing. And there's your quadratic formula. I used to love to show kids this when I was teaching in the classroom and stuff. I thought it was fun. They were always amazed. But anyway, so there's your quadratic formula, and we got it all by completing the square. So that's why it's important to know how to complete the square. But, so to actually use the quadratic formula to solve something, so we have number 15. We have x squared plus 5x plus 6 is equal to 0. So for a quadratic formula, you want the one side equal to 0, typically the right. But for factoring and quadratic formula, you want one side equal to 0, just completing the squares where you want to move it. So in this case, my a is 1, my b is 5, and my c is 6. So x is equal to negative b, so negative 5, plus or minus the square root of b squared, so 5 squared, minus, and I usually throw parentheses around these unless it's positive. If it's negative, I do put parentheses so you don't forget about the negative. But anyways, minus 4 times a is 1 times c is 6, all divided by 2a, so 2 times 1. So that gives me negative 5 plus or minus, if you simplify this, 25 minus 24 is 1, and 2 times 1 is 2. So I have x is negative 5 plus or minus 1 divided by 2. So you still got two solutions. So we have x is either negative 5 plus 1 divided by 2, which is negative 4 plus, negative 4 divided by 2 is negative 2, or negative 5 minus 1, which is negative 6 divided by 2 is negative 3. So there's my two answers using the quadratic formula. So the quadratic formula is also relatively fast. If you have one that's not equal to 0, so if you have like x squared is equal to negative 3x plus 7, then you want to get one side equal to 0 and the other side everything else. So typically I'll leave x squared on the left and get 0 on the right. So I'm going to add 3x. I'm going to subtract 7. And now I have 0. So in this case, a is 1, b is 3, and c is negative 7. So I'm going to plug all that in. So I've got negative b, so negative 3, plus or minus the square root of b squared, so 3 squared, minus 4 times a is 1. If a is 1, you don't really have to write it down, but just for the sake of showing you, times c is negative 7, all divided by 2 times 1, which is just 2. And if I try to simplify this one, I get negative 3 plus or minus the square root of 3 squareds, 9 minus 4 times, or negative 4 times negative 7 is 28. So 9 and 28 is 37, all divided by 2. And you can't do anything with 37. It doesn't have a perfect square in it, so you can just stop. You don't have to try to do a decimal form or anything. You can just leave the answer like that. It's fine. You can check it on the calculator. It's kind of a pain when you have to plug it in like this, but you can do that. Like I said, if you do a decimal and round, when you check it on the calculator, it might throw it off by a little bit, but just you don't have to get a decimal answer. So if we have one like number 18, you have 6b squared plus 5b minus 4 is equal to b squared plus b plus 1. So again, you want to get the one side 0. So I'm going to subtract b squared over. So I've got 6b squared minus b squared is 5b squared. I'm going to subtract b. So 5b minus b is 4b. And then I'm going to subtract 1. Negative 4 minus 1 is minus 5 is equal to 0. So now I've got a is 5, b is 4. All these b's are positive, but I think there's one. Maybe I skipped it. That was negative. But anyways, just be careful. If b is negative, it's minus a negative, which turns it positive. So negative b. So this is like if this were negative 4, it'd be negative. Negative 4 should be positive. So just watch that. Negative b plus or minus the square root of b squared. So 4 squared minus 4 times a is 5 times c is negative 5. All divided by 2 times a, which is 5. And then just simplify. So I've got, if I simplify this, it's 116 divided by 10. And if you can reduce, so you can leave your answers in radical form, that's fine. But if you can simplify the radical, you need to do that. So 116 is 4 times 29. And the square root of 4 is 2. So I can say that this is negative 4 plus or minus 2 square root of 29 divided by 10. And then all of these have a 2, which means I can take that out. So it's equivalent to negative 2 plus or minus the square root of 29 divided by 5. And then you can't reduce that any further. So if you can reduce the fraction, you should, and then you can simplify it as far as you can, but, or not the fraction, the radical, and then the fraction you can, but then once you get to here, if nothing else reduces, just leave it alone. Oh, number 19, it has a b as negative, so just be careful. I didn't start this one, but just to point it out here. So negative 3 becomes positive 3, and then when you square the negative, it also becomes positive. So just watch it. Watch your positives and negatives on the formula. So to do one application and then some graphs, and we'll be done with this. Instead of writing all this out again, I'll just sort of read it to you. The length of a rectangle, so let me draw a rectangle, is, I can't read and draw at the same time. The length of a rectangle is 18 inches more than 3 times its width, and the area is 81 inches squared. So my area of my rectangle is 81 inches squared. My width's here, and my length, it said, was 18 more than 3 times its width. And I mentioned before when we were doing this, anytime you have the word more than, write whatever is after than first, just because then you get in the habit of doing that. So if it was less than, you'd have it in the right order. But anyway, so 3 times its width, so 3w plus 18. It doesn't really matter on a more than, but it does matter on a less than. But anyway, so find the dimensions. So we want to find what are my L and W. So area is length times width. So it tells me my area is 81. My length, I just said, was 3w plus 18 times width is just w. So solve this. If I distribute my w, I get 3w squared plus 18w. So I have a quadratic to solve. Now you can pick if you want to solve by completing the square, quadratic formula, whatever you want to do, you can decide. I try to factor. If it'll factor, this will factor. And so I've got 0 on the left. Normally I go the other way, but it doesn't matter. And I can take out a 3. My greatest common factor is 3, just to make my numbers smaller. So I've got w squared plus 6w minus 27. And then that factors into w plus 9 times w minus 3. Because you have w squared minus 3w plus 9w, 6w, and then negative 27 when you multiply 9 and negative 3. So then 3 can't be 0, so we just skip it. So w plus 9 would be 0. Or w minus 3 would be 0. Well, if we're talking about width, we can't use this one because width can't be negative, so it's an extraneous solution. Throw it out. So the only option we have is 3. So my width has to be 3, which means my length has to be 3 times 3 plus 18, which is 27. So my width is 3 inches and my length is 27 inches. And we found that by solving the quadratic and doing factoring. And you'd get the same answer no matter what method you used. And you just have to, if it's an application, sometimes you might have to throw a solution out. So last one here, we're going to graph a quadratic. And there's steps for graphing, so I'm just going to kind of explain them as I go. And I have them all wrote down. I don't have these numbered, but I have them all wrote down on the notes. When you look at it on the examples and stuff, I've got it labeled as to what I'm doing. So the graph of a quadratic is a parabola, so it either looks like a U going up or an upside down U. So what I always do is I still write down my A, B, and C. Okay, and you have f of x or y equals, so f of x is just the function notation. So the first thing you can decide is if it opens up or down. So you look at A. So if my A is less than 0, in this case it is, it's negative, it's less than 0, that means the parabola opens down. So this one's going to go this way. If it was greater than 0, if A was greater than 0, it would go this way. It would open up. I can still find my intercepts for a graph, just like always. So I can still do my y-intercept, which is plugging in x is 0. So if you plug in x is 0, and I have it all wrote out if you look at it, but just to show you the quicker way, 0 squared is 0, minus 2 times 0 is 0, is all this gone. So basically all that you're left with is your constant term. So y is 3. So I have the point 0, 3 is my y-intercept. So anytime you do your y-intercept, you're only going to be left with the constant. My x-intercept is when y is 0. So I'll set this equal to 0. So 0 is negative x squared minus 2x plus 3. So you have to solve the quadratic. So when I solved it, I multiplied by negative 1. So that way my x squared was positive instead of negative. It's a lot easier to deal with if your x squared is positive. Then you can factor, you can use quadratic formula, you can use completing the square, whatever method you want to use. If it factors, not all quadratics factor, but this one does factor. It's x plus 3 times x minus 1. So x plus 3 is 0, which means x is negative 3, or x minus 1 is 0, which means x is 1. So you have the point negative 3, 0, or 1, 0. Those are my two x-intercepts. Okay, so the intercepts are the same as when we were doing lines. When we were doing lines, plugging in zeros for x and 0 for y. For the intercepts, it's just now when you do the x-intercept, you'll have a quadratic to solve. Then you also have what's called axis of symmetry, because a quadratic has to be symmetric. So if you draw a vertical line down it in the middle, the left side has to match the right side. So that is negative b over 2a. Now some people don't always figure out what this is, and I don't specifically ask for it on the homework, but if you want to know what it is, you can always do it. So negative b, so I've got negative 2 is my b, over 2 times a is negative 1. So that is negative 2 is 2, over negative 2 is negative 1. So my axis of symmetry is negative 1. X equals negative 1. So if I draw a vertical line down negative 1, the left side should match the right side. And then the last thing you want to know for a parabola, for a quadratic, is the vertex. So the vertex xy is the point, negative b over 2a, which we just said was negative 1, and then f of negative b over 2a, which just means plug that in and see what you get. So I already know negative b over 2a is negative 1. And then I need my y value. So if I plug in a negative 1, so f of negative 1, if I plug that in, what do I get? So plug in negative 1 for x. So I've got, let me do f of negative 1 here. That's just function notation. So I've got negative 1 squared. I'm just plugging it in for x, minus 2 times negative 1 plus 3. So that is 1 plus 2 plus 3. Oops, I think I made a mistake on the notes. That should be a 6. I wrote a 4. Negative. Wait a minute. Oh, I'm plugging it into the wrong thing. I'm plugging it in over here. This isn't the same thing. So I should have a negative here. And okay, now I'm okay. sorry, I forgot my negative up here, negative x squared. So I've got negative, so it's a negative x squared, so negative negative 1 squared. I'll get it right in a minute here. So negative x squared. So negative negative 1 squared is positive 1, but the negative's on the outside, so it's still negative. Negative minus 2 times negative 1 is still positive 2, and then plus 3. And now I'm okay, right? Because, okay, yeah. So now negative 1 plus 2 is 1, plus 3 is 4. Okay, sorry. I forgot my negative was out here on the x squared. Negatives can be tricky. Sometimes you forget about them or lose them. Anyways, sorry about that. So the negative's on the outside, so keep it negative. So negative 1 plus 2 plus 3 is 4. Okay. So now I can draw my graph. So I'm going to have my intercepts. I've got 0, 3. So 1, 2, 3 is my y-intercept. I'll put a 3 here if you want. My x-intercepts are negative 3, 0. So I'll go over 3, 1, 2, 3. And these don't have to be perfect. You know, just if you tell me all the points, then I know what you've done. 1. And my vertex is negative 1, 4. So I'll go negative 1 up to 4 here. So negative 1, 4. And the axis of symmetry, so let me connect these like with the U-shaped as much as I can. Like I said, I'm not very good at drawing. So if I drew this axis of symmetry in and I folded it this side, which mine doesn't, I didn't hit the angle right, but anyways, the idea is that if I fold it on this line, this side will match that side. And if yours doesn't, that's okay, as long as you have your points correct and stuff. And you can label these points if you want to help. This is your vertex, which is negative 1, 4. So the left side should match the right side, but if you're not very good at drawing, kind of like me, then yours probably done, but that's okay. So that's how you graph a quadratic. So several pieces of information gives you enough points to be able to draw the parabola. So intercepts are important, the vertex is important, the axis isn't as important. You should just know that the left should match the right and it's always at the vertex. And then like I said, A, if it's greater than 0, it opens up. If it's less than 0, it opens down. So that is all we have for quadratics. So if you have any questions about anything, please just send me a message.